This happened in August 2025, and people are still trying to understand the shockwave it created. Nvidia stepped onto a stage and revealed a device that looked harmless, almost ordinary, yet its potential could reorder the global economy. They called it Jetson Thor. In that moment, something shifted, because this wasn't a chip upgrade or a technical announcement. It was a declaration that robots were about to stop following instructions and start making decisions. The moment the future arrived, every major revolution begins quietly. There is no thunder, no explosion, just a single moment where the world changes direction. Jetson Thor was exactly that kind of moment. The world had seen AI evolve rapidly in software. We had chatbots that could write essays, generate art, or pass exams, but the physical world remained stubbornly resistant. A robot could lift heavy loads, but it couldn't understand a room, predict danger, respond to surprises, or improvise solutions when the unexpected happened. The problem was always the same. No robot had a brain powerful enough to process the chaos of real environments in real time. Factories are unpredictable. Warehouses are messy. Construction sites change every hour. Agriculture is shaped by weather, soil, terrain, pests, and thousands of variables. And the truth is, human workers were still irreplaceable, not because robots lacked strength, but because they lacked perception and judgment. Jetson Thor is the first brain that changes that. It is the first robotics computing platform built to handle the level of understanding, reasoning, and coordination required to navigate unpredictable, three-dimensional, living environments. For the robotics world, this was the moment they had been waiting for. The instant Thor appeared, researchers, engineers, founders, and factory owners all knew the same thing. Robots were no longer limited by software, they were limited by imagination, and that barrier had just collapsed. Inside companies around the world, emails poured in from engineers saying, "We can finally build what we've been trying to build for years." Startups that were stuck suddenly had a path forward. Companies that believed they had 10 years before robots replaced labor started recalculating in panic. Thor didn't just shift expectations, it accelerated the future. What Jetson Thor really is officially described as an embedded AI supercomputer. But that phrase doesn't capture its reality. It is essentially a pocket-sized data center that a robot can carry inside itself. It has computing power far beyond anything that has ever been placed into an embedded platform before. It has enough memory to run massive multimodal AI models directly on board. It can process high-resolution camera feeds, depth maps, LiDAR streams, radar inputs, environmental readings, tactile sensors, and real-time control loops all at once. That matters because physical AI requires understanding the world in the same instant it acts inside it. A robot trying to avoid a falling object cannot wait for cloud latency. A robot trying to understand a worker's hand signal cannot rely on a slow external server. A robot carrying fragile materials must detect subtle shifts in weight and adjust immediately. Jetson Thor's architecture is built precisely for this. Extremely high bandwidth, rapid sensor fusion, instant decision-making, and continuous control. For the first time, a robot can run foundation-level AI models, the kind normally used in cloud servers, directly inside itself. It can understand language, identify objects, reason about context, predict movement, and adapt its behavior. That means robots can finally handle the ambiguity, unpredictability, and dynamism that once required human minds. Before Thor, robots followed instructions. After Thor, robots can interpret the world. The first companies to see the opportunity. The robotics industry responded instantly. Agility Robotics, whose humanoid Digit had already proven mobility and balance, immediately announced integration with Jetson Thor. With Thor, Digit would no longer operate like a programmed machine. It would perceive tasks, understand warehouse layouts, identify errors, and modify its behavior as conditions change. Suddenly, a humanoid robot wasn't just a prototype, it was a worker. Boston Dynamics, known for pushing the frontier of mechanical design, saw Thor as the key to unlocking real autonomy. Their robots could already jump, sprint, carry, climb, and maneuver in environments humans struggled with, but they lacked the intelligence needed for independent decision-making. Thor gives them that intelligence. A Boston Dynamics robot with Thor could walk into a construction site, understand obstacles, interpret layouts, plan routes, and work with human crews without constant supervision. Something that once felt like science fiction began to feel practical. Heavy machinery companies in mining, farming, and construction quickly joined the wave. Thor provides the processing power to analyze soil conditions, detect hazards, create excavation plans, coordinate with other machines, or even understand spoken commands from workers in the field. Traditional industries that were always too chaotic for automation suddenly became candidates for full autonomy. Even more quietly, dozens of small robotic startups began reworking their entire product lines. Thor allowed them to build machines they had only been able to dream of: autonomous inspection robots, cleaning robots, security robots, medical assist robots, agricultural harvesters, and last-mile delivery units capable of navigating real-world environments without failing at the first unexpected obstacle. Thor didn't just accelerate robotics giants, it unlocked robotics for everyone, the industries that will transform. First factories are always the first to feel the shock of automation, and this time will be no different. The assembly line robot arms of the past were powerful but unintelligent. They could weld, lift, or screw parts together, but only if everything stayed in perfect alignment. Thor-equipped robots do not need perfect alignment. They can interpret misaligned objects, correct their actions, detect defects, adjust their technique, and switch tasks without reprogramming. Imagine a factory where robots don't stand in fixed lines but move freely, dynamically choosing tasks based on real-time needs. Imagine inventory systems where robots never miscount, misplace, or mishandle goods. With Thor, factory floors evolve from rigid mechanical systems into adaptable, intelligent operations. Warehouses will follow the same transformation. Thor-powered robots can navigate tight aisles, avoid forklifts, identify damaged items, sort products accurately, and reorganize shelves on the fly. Large logistics companies dream of warehouses that run all night with no human workers. Thor makes that vision achievable. Agriculture, long considered too unpredictable for automation, is next. A Thor-equipped field robot can analyze crop health, detect diseases, identify weeds, adjust watering patterns, and navigate uneven terrain. On large farms, autonomous robots could work around the clock, increasing yield and reducing labor costs dramatically. Construction, one of the most dangerous professions on Earth, will also change. Robots capable of understanding physical structures, predicting risks, and navigating debris could take over repetitive or high-risk tasks. From carrying materials to preparing surfaces or mapping out work areas, Thor gives construction robots the ability to adapt in real time. Healthcare will experience a quieter but equally significant shift. Robots with Thor will handle hospital logistics, transporting medications, sterilizing rooms, monitoring vital signs, delivering equipment, or supporting nurses during emergencies. Unlike cloud-dependent robots, Thor-enabled machines can make life-critical decisions instantly inside the hospital without delays. This is the first time automation becomes universal, not specialized. The consequences the world is not prepared for Jetson. Thor is a technological achievement, but its impact reaches far beyond engineering. It forces a societal reckoning. Labor disruption becomes unavoidable. Jobs once considered secure because they required adaptability will be threatened by robots that can adapt even faster. A robot doesn't forget instructions, get tired, get distracted, or lose motivation. Once one robot learns something, the entire fleet can learn it instantly. Economies that rely on cheap labor will face immense pressure. Manufacturing-heavy countries may watch automation reshape global competition. Nations with strong robotics adoption will benefit. Nations without it may watch industries exit overnight. Regulation becomes urgent. Governments will need to answer difficult questions. Who is responsible if a robot makes a mistake? How do we certify robots that think independently? What rights do workers have when replaced by AI-driven machines? What data is a robot allowed to collect inside workplaces? Education systems will need to shift toward robotics literacy, AI oversight, and advanced mechanical skills. New jobs will appear, but they will require training, not physical strength. The world is entering a period where the definition of work itself may need restructuring, and Jetson Thor is one of the catalysts pushing us toward that future faster than expected. Why Jetson Thor is a turning point. History rarely reveals its turning points as they happen, but Jetson Thor is one of those rare exceptions. It marks the moment when robots stopped being rigid tools and began transitioning into thinking participants inside the physical world. This is not evolution, it is a leap. Thor-powered robots won't just replace labor, they will reshape industries from the ground up. Factories will redesign workflows to suit intelligent machines instead of humans. Warehouses will operate on continuous robotic coordination. Farms will run optimized cycles driven by constant environmental analysis. Construction sites will become safer as machines take over danger zones. Hospitals will increase efficiency with robotic assistance. This is the birth of physical AI at scale. The rise of general-purpose robots. The beginning of a world where intelligence is not limited to screens but lives inside the machines shaping our environment. The question is not whether this will change the world. The question is how fast. If you want to stay ahead while the world enters this new age of physical AI, make sure you subscribe to the channel. We break down the breakthroughs most people won't hear about until they've already transformed entire industries. Hit the like button, share this video with someone who needs to understand how fast automation is accelerating, and stay tuned, because the next chapter of robotics is coming faster than anyone expects, and we'll be here to cover every part of it.